here's some things I want you to notice before we start graphing these parabolas and then talking about the attributes of it. With your highlighter, please, I would like for you to highlight this parent function, or not parent function, that's the wrong phrase, this standard form function up at the top of your paper. Now, this should look familiar to us. This should look familiar to us. What do you notice about what I just highlighted in red? What does it look familiar to you?
Yes, A, B, and C.
If there's an A, B, and C, and somebody said the f of x looks familiar. Cool. Function notation is going to happen a lot in this unit. But then people have also said A, B, and C. Where have we seen A, B, and C before?
ABC
News.
I mean, I guess you're not wrong. ABC News is a thing. But where in math class, most recently, what is over there? What is that? What are you pointing at? Factoring. That's what I'm looking for. Okay. Even on our quiz today, when we were going to factor that polynomial, we had to know what A, B, and C was so that we could factor it. Those are the same A, B's, and C's here. So we're using the same functions, but now we're not just going to be factoring them. We're going to be graphing them and telling the attributes. All of the parabolas you did last time and on your homework, were made from functions like this. So I need you to now highlight the first equation that we're given. This is the first one that we're going to graph and identify its attributes. If we were going to factor this, which we're not, the first thing we'd do is to identify A, B, and C. What's A here? Ooh. Ooh. It's next to the x squared.
A squared.
I heard it. It's 1.
Yes.
What's B?
4.
Just 4. What's C?
-5.
Cool. That's A, B, and C. That's what we would have done with our factoring. Last time we talked about one of our vocabulary words being a positive A value. We have a positive A value here because you guys just told me it's 1. So should this graph be a happy parabola or a sad parabola?
Happy parabola.
Cool. That's the number one way to check your work. If you know it should be happy and all of a sudden you have a negative parabola, something wrong happened. Okay? Cool. Here's what we're going to do. You're going to take this function that we highlighted in blue. You're going to type the whole thing into Desmos with the f of x included. So you're going to type f of x equal to x squared plus 4x minus 5. Now, I cannot show on here and on, I can't show the notes and Desmos at the same time, so I'm going to cut away to Desmos. But just know I'm looking at Desmos just like you should be as well. From your Desmos screen, I need you to poke the parabola with your finger. It's touchscreen, right? Poke the parabola. What comes up when you poke the parabola?
A number.
What number?
-2/-9.
Where are you poking to find -2/-9? And by slash you mean comma. Do you notice that there are points that are highlighted on this parabola when it's in Desmos? What points are they? The vertex was one of them. That's what Angel just told us.
-0, 1 and 0,
And
0 and
the
-5.
roots.
The roots are highlighted. There's one more thing that's highlighted.
And
The
axis.
The y-intercept. Axis of symmetry is not shown, but I'm going to show you what to do with that in a second. So we have a bunch of coordinate points that are a part of this graph. You could make a table and plot all these points if you wanted, or you just take those numbers from Desmos that you guys just told me, which was that the vertex was at -2, -9, that the y-intercept was at, what was it?
Yes.
Wait,
What was it?
what did you say?
-5. And where were my roots at?
-5 and 1.
Yeah.
So I can plot all those points on my notes. Boom, I just plotted them. And then I can play connect the dots to, not very well, because I'm real bad at this part, make a parabola. Please don't laugh.
It's okay, miss.
Yes.
I'm laughing hard.
You know what? Honestly, that's one of my best ones all day.
Woo!
Only the best for you guys.
Congratulations.
Thank you. Now there's 2 things I need to have happen when you make a parabola for me. 1, it actually goes through all the dots. Don't just willy-nilly draw you. It has to make sure it goes through the dots. 2, these don't ever stop. So don't stop right here. They're going to keep going and going and going. They must end in arrows on both sides. Okay? So make sure you play connect the dots, but also give me endpoints that are arrows because it's going to indicate that this graph keeps going forever and ever. Now, we're humans, so we make the ugliest parabola as possible, but that's why you have Desmos making a nice pretty one, because computers can graph more accurately than humans. I mean, that's just their thing. And now that we have it graphed, we kind of go back to what we did before and answer all the vocabulary questions. If we were looking at this graph, and you've already kind of told me, and it's in your Desmos, what's your vertex?
-8. B -9.
So your vertex is a coordinate point?
-2,
-2, -9, that's your vertex. Plus, that's one of the points that comes up on your Desmos. It will tell you the vertex. What did you guys tell me were the roots?
-5 and 1.
So you could write it just like across the classroom was said. You could write -5 and 1 for all of these, or you can write the coordinates of -5, comma 0 and 1, comma 0. Either of them are appropriate. In fact, it's most appropriate to write the coordinates for the x-intercepts and then the numbers for the roots, zeros, and solutions. But honestly, it doesn't matter as long as you're telling me the right numbers. Now, does this one have a maximum or a minimum value?
Minimum.
Minimum. And what is that minimum? How low does it go? -9 is as low as it goes. That's my minimum value. Now, axis of symmetry is really cool on Desmos because a lot of times we're like, I hope this question's right. You can check your work now. What do we know is the axis of symmetry here? It should cut it in the middle, right? And I heard conflicting answers. I heard x equal -2 and I heard x equal 9. I want you to pick one and I want you to write it down. Or sorry, graph it in Desmos. If you think it's x equal 2, or sorry, -2 and x equal 9, I need you to pick one, whichever one you think it is, and I need you to type that into Desmos. Because if you pick one and it doesn't go straight through the coordinate of the vertex, that's not the axis of symmetry, so you should not pick that. -2. Try -2. When you type in x equal -2, doesn't it cut that parabola exactly in half?
Yeah.
That means this one would be my axis of symmetry, not that one. So we'd answer that the axis of symmetry is x equal -2. 100% you should get that answer right because we can put it into Desmos and make sure it cuts our graph in half. By the way, if you want to make it a dashed line in Desmos, because you want it to look like the dashed lines we draw on our papers, click and hold on the color, and there's options that you can change the color and change the style so it can be dashed. Let me show you what I mean. All right, we've also already identified the y-intercept because that's one of the coordinates that Desmos will tell me. What was the coordinate of the y-intercept? 0, -5. Very good. That one is a coordinate, so I do need the whole thing, but if you click your screen, that's exactly where Desmos tells you it is.
Oh.
Ooh, crossing my fingers that we answer this one right. What's the domain of this function?
All real numbers.
Beautiful. Now the range is maybe the one that we mess up on. Range is what letter? Y.
It's where
And it's going to be something to do with -9. Yeah, this whole graph is above -9. Like if I drew a line at -9, which is my minimum, you tell me the whole blue thing shows up above it, right?
Yeah.
Not below it, above it. So we use the above symbol, which is greater than or equal to. If you need to write that down for yourself one more time, that greater than or equal to is above,
Yeah.
and less than or equal to is below. That might be something nice to have written on your paper just one more time
Yeah.
until we have it memorized. Oh, it's always cold in here. All right. Delete everything out of your Desmos. Open your booklet. You've got number 1, the notes.
Oh.
Open up to number 1. You've got number 1. I want to see if you can do all of number 1 on your own. Are you ready?
Yes.
You got it. I believe in you.
Many people.
So we graph this function, and yes, it's the exact same. I wanted to see if you could do it without using the questions we've done before. But all of these points should still be the same. And if I was playing connect the dots, to get very accurate, I would use more points from a table. Ooh, that's actually not bad either. But again, our vertex is still in the same spot of -2, -9. Our roots are still at -5 and 1, which I can write like this. Or I can write as coordinates like I should.
Yes.
Either are appropriate, like I've been saying. This one has a minimum value at -9. Its axis of symmetry is x equal -2. Its y-intercept is 0, -5. Has a domain of all real numbers and a range of y greater than or equal to -9. Sweet. Here's what we're going to do. We're going to split up the next two questions. If you're sitting in a desk labeled A, congratulations, you have the easier question. 2 is yours. If you're sitting in a desk labeled B, congratulations, you get the challenge question. You've got number 3. You can still do it. It's the same thing. It's only the challenge question because it's a little bit big, is all I'm going to say.
Miss, we doing?
You have 2 minutes to get your entire question answered, all parts of it and it graphed. At the end of 2 minutes, you're going to trade like with your teammate. You're going to tell your face partner the answers to yours and they're going to check your work. Bless you. Okay, so 2 minutes on the clock. You've got one question to do. Here we go with some clarifications. Partner A was doing number 2. They should have graphed this and it would have looked something like this. We had a coordinate up here, a coordinate here, and a coordinate here, which is all that it gave you as important points from Desmos. That's fine. We can draw a quadratic. Ooh, that one's not so good. But we know from Desmos that my vertex is at 0, 4. Did we get that one right?
Yes.
Yay. Our roots are at -2 and 2.
Yes.
Okay, I saw some people write it like this. Is this the right answer? No, that's a coordinate. That's not where my zeros are. So you do need to make sure that you write it as -2 and 2. Or you write it as both of their individual coordinates of 2, 0 and -2, 0. But all of my rocks words are the same. Oop, almost wrote it wrong. Does this one, my friends who did answer choice or number 2, is this a maximum or a minimum?
Maximum.
Maximum. What is that maximum value?
4.
4. Very good. Nothing goes higher than 4 here. That's where its turning point is. The axis of symmetry, what was it?
25.
The axis of symmetry was x equal 25?
No. 4.
All right, everyone type into their computer x equal 4.
You actually said it too.
Is that right there?
No.
X equal 4 is right there. Is that in the middle?
No.
No.
It's x equals 0.
It is x equals 0. X equals 0 is the line that goes right through the center because that's the x value. The y-intercept actually tripped people up on this question all day. The y-intercept is where the graph crosses the y-axis. Where does this one cross the y-axis? It's the same thing as the vertex. That's okay. Sometimes the vertex is also the y-intercept. That's totally allowed. So we could write down 0, 4 as my y-intercept. Friends, what's the domain here? Beautiful. And the range has to do with that max value. Is the whole graph above or below? Which is less than or equal to. Very good. Thank you, partner A's, for doing your problem. We're going to go to partner B's here and work on partner B. Partner B, you had the harder one, so thank you for taking the challenge.
I only got two left.
Hard work.
When we type this into Desmos, you would have seen a really long, skinny graph, right?
Yeah.
It had a point that showed up at 3.5, 12.5, which is approximately there. Had a coordinate at 1, had a coordinate at 6. Is that right?
Yep.
And then had a coordinate at -12, which is way down there. Yeah, here's my really bad parabola that's going to come. Oop, straight up missed that one. That's fine. Okay. Man, do better than me, please. Be a better parabola drawer than me.
It looks like that first
Is this good? Is this good?
It looks great. Actually, that looks really good. I'm going to wait that I didn't do that good. Okay, but we know that the vertex is at that top point, which Desmos tell me is 3.5, 12.5. Yes, that is part of it. You might get some decimals in your vertexes, in your roots, in your zeros. That's fine. That's where it's showing up. What was the roots, my friends who did this one?
1 and 6.
1 and 6.
1, 0, 6, 0, or you could say 1 and 6. Very good. Either of these is fine to say. 1 and 6. Friends who did this one, does this have a maximum or a minimum? And what is that highest height that it gets to? 12.5. Remember, the max value is how tall or how small that graph is. What's the axis of symmetry here?
12.
So that's just a number.
Oh, x equals 12, sorry.
Thank you. And to be more accurate, it should be,
Sorry.
is this right?
No, it's x equals
Remember, it's the x value of the vertex. This should be the x value from the vertex. But if we were confused and tried 12.5, because guaranteed they're going to make that an answer choice, you would see that that did not go through the center, and that the only one that goes through the center is when we make that x equals 3.5. And there's our actual axis of symmetry. What was Desmos telling me the y-intercept was?
12.
That's again a number.
So 0, 12.
0, comma 12. Very good. It's a coordinate, so we have to tell it like a coordinate. What's the domain?
All real numbers.
All real numbers.
And the range is all
Less than equals to 12.
Y
Less
is
than 12.5.
is all below 12.5, which is less than. Very good. Okay, so I know I went through these two examples pretty fast, but you talked them out with your partner, so we should have them. We got to talk about this last one on your paper. What do you notice about this equation?
It doesn't have an ABC.
This is none of
Does it have a A?
No.
Ooh.
Wait, yes, but it doesn't have
It doesn't have a B or C. This is a really boring version of a quadratic. In fact, it's so boring but so important that we renumbered it number 1 because it's that important. This is the number 1 thing you need to know today. This boring version of this function is called the parent function. Every type of function we study has a parent function, and it's the most basic version. Starting next class, what's going to happen is we're going to take this parent function and we're going to start making other parabolas from it, because it's the OG parabola. Every other parabola is made by doing stuff to this one, sliding it around, flipping it over, making it big or small. They're all made from this one, so this one's super important to know. When you type this into Desmos, what does it look like?
You only got 1 point.
We only got one.
It only has one important point that shows up,
Yep.
and what is it?
0.
0, 0. Is this a happy parabola or a sad parabola? You could get really accurate, over 1, up 1, over 2, up 4, both directions to really get a good graph, or you just give me a good sketch, okay? I don't care how accurate you get today. Ooh, this one's bad.
It's okay.
That's so bad. Hold on, I'm going to redo it because that's just really
That's good.
I just can't stand for that. Miss Jackson's laughing at my inabilities.
How is
Y'all are so much better at drawing parabolas than me.
I don't understand. How am I better than you? How am I better than you?
It looks great. Okay,
On the iPad,
it's hard.
because you can't.
You can't put your wrist down so it's like all like balanced with the pencil. It's really hard to draw, you know? Okay,
Okay, now I
now
understand how I'm better than you.
let's talk about the important attributes of the boring function, of the parent function. What's the vertex?
0, 0.
Cool, that's where it turns. What's the root?
Doesn't have one.
Are you sure though?
Negative 1 and 1.
0.
It crosses right here, the x-axis at -1 and 1? Only 0, right?
Oh, it's 0, 0.
So this is the only place where the root appears. Okay, there's only 1 and it's 0, which means the 0 is 0. And the x-intercept is 0. And the solution is 0. Is this a max or a min?
Minimum dollar.
Minimum. And what is that minimum value? You see what's happening here? What's the axis of symmetry?
0, x equals 0.
Very good, because if I were to actually draw that in, that would show up here at 0. This would be the line that cut it in half. And you could test that out in Desmos. What's the y-intercept?
0 over 0.
0, 0.
See how boring this is? What's the domain?
All real numbers.
Thank you for not saying 0. The domain is still all real numbers. But what's the range?
Y greater than 0.
Y'all, the parent function is the most boring version because it all has to do with the origin here. This is the only coordinate point that is one of my attributes here. It's basically the whole thing. It's both the vertex, the y-intercept, the x-intercept, the roots, the zeros, the solutions, and the minimum value. Super boring, but very important. Because every other parabola is made from this parabola. Starting next class, I'm going to teach you what that means. So we're going to take this parabola and we're going to twist it around and make it cool. We're going to translate, dilate, and reflect it, which are all things you know how to do with shapes from 8th grade.
I'd be like, hey, Dad.